At some point, you may have thought, do all neurons have the same conduction velocity, or do certain neurons have different conduction velocities? And if so, why? In this experiment, you'll record the conduction velocity of the earthworm's lateral and medial giant fibers. Both fibers run the length of the worm, but each fiber serves a different purpose in the earthworm's nervous system. Let's get started. In this experiment, I will be using a 10% alcohol solution to anesthetize the earthworm. However, if you do not have alcohol available, seltzer water, which is pure carbon dioxide, can be used as an alternative instead. Set your stopwatch for about 4 minutes, then place the worm inside the anesthetic bath. Now that approximately 4 minutes have passed, take the earthworm out of the anesthetic bath and place it in the water bath. The water bath washes excess alcohol off of the worm. This experiment is in many ways just like the first earthworm experiment. Place the worm dorsal side up so the dark side of the worm faces up towards you. Also, make sure that the posterior or back end of the worm is closer to the left edge. Start by inserting the electrodes into the worm, slightly off the center line. Place electrode 1 closer to the posterior end of the worm and electrode 2 half an inch further up the worm. Place the final ground electrode near the anterior or front end of the worm. Now place the earthworm into the Faraday cage with the worm's posterior end facing towards you. Once the spiker box is turned on and Audacity is recording, you will start recording from the posterior or back end of the worm. Now let's listen for the sound of some glorious, beautiful spikes. When you touch the posterior end of the worm, you hear some great sounding spikes. Once you hear those great sounding spikes, you will want to turn off the spiker box, but you must not stop Audacity. Allow it to continue recording without interruption. Now that you have turned off the spiker box, remove the worm from the Faraday cage and take out electrodes 1 and 2 and the ground. Next, spin the worm around 180 degrees. Ensure the dorsal or dark side of the worm continues to face up towards you. Finally, you'll replace the 3 electrodes. Electrode 1 will be at the anterior end of the worm, and the ground electrode will be at the worm's posterior end. Now place the earthworm with its anterior side facing you back in the Faraday cage, and turn the spiker box back on. Don't forget, you do not want to stop your Audacity recording during the experiment. That sounds like great neural activity to me. Once you hear some good spikes, go ahead and turn off the spiker box and stop the Audacity recording. Return the earthworm to its box and clean your electrodes. Next, you will be taking a closer look at the data you just recorded. Here's the Audacity recording we just took. The first group of spikes highlighted are your posterior lateral giant fiber recordings. The lateral fiber receives sensory information from the posterior end of the worm. This middle flatline area is where you turn off the spiker box. This was done to create an easily recognizable area that separates your posterior and anterior data. This last group of spikes highlighted are your anterior medial giant fiber recordings. The medial fiber receives sensory information from the anterior end of the worm. Now you want to zoom in on one of the posterior spikes in the first group so we can figure out the conduction velocity. Continue to zoom in. You want to be able to see each spike in great detail so you can see which spike belongs to electrode 1 and electrode 2. Now you can see both channels. The first spike is electrode 1 and the second spike is electrode 2. Conduction velocity is measured in meters per second or meters over seconds, so you want distance and time. Time is the milliseconds it took to go from electrode 1 to electrode 2. You essentially want to find out how many milliseconds elapsed in the highlighted area. That is, how many milliseconds was it between electrode 1's dip and electrode 2's dip. One easy way to find this is go down to the selection start area at the bottom of Audacity and make sure you have the length button checked. Then click on the drop-down menu and make sure you have hours, minutes, seconds, plus milliseconds selected. Next, you want to click on the bottom of electrode 1's dip and drag the mouse to the bottom of electrode 2's dip so that you highlight the area in between the two. Once you've done that, look back down at the bottom of Audacity, and right below where you previously clicked the length button, you'll see 0.002 seconds, which equals 2 milliseconds. 2 milliseconds is the time between when the spike passed electrode 1 and electrode 2. Now let's go find the time for one of the anterior recordings.
Remember, conduction velocity is a measurement of distance over time. We already have our distance. This was how far apart electrode 1 and 2 were, which was 0.5 inches. We just got the time for the posterior spike. Now we're going to go get it for the anterior spike so we can compare the two. And once we've highlighted the area, we see that there is a time of 1 millisecond. But are we really happy with the measurement of 1 millisecond? Can we get a more accurate measurement? What if we try to zoom in on each dip and get a precise time for each electrode? We can then subtract electrode 1's time from electrode 2's time for a more precise measurement. Go ahead and zoom in on the first electrode and click at the very bottom of the dip and look at the very top, and you can find an exact time of 34.9084 seconds. And now you're going to go ahead and do that for the second electrode. And you get a time of 34.9089 seconds for electrode 2. And then if you go ahead and subtract electrode 1's time from electrode 2's time, you'll wind up with 0.0005 seconds, or half a millisecond. Now, this is a big difference from what we originally got, which was 1 millisecond was the other method. While half a millisecond may not seem like a big deal, the impact it has on the final result will be huge. Remember, the purpose of this experiment was to compare the conduction velocity from the posterior and anterior end of the earthworm. You want to see if there is a difference or if they are actually the same. Because conduction velocity is measured in distance over time, you need to collect both of those measurements. Distance is easy because it is how far apart the electrodes are placed in the worm. Time is a bit trickier and requires you to find the millisecond difference between the two electrodes. Here are the final results. Remember when we were looking at the anterior spike and at first we had measured a time difference of 0.001 second or 1 millisecond? If we substitute 0.001 seconds in for the anterior's 0.0005 seconds, we will get a conduction velocity of about 12.5 meters per second. This is a huge difference, and it really highlights how the methods you choose to analyze your data can have large impacts on the final results. From these two measurements, it seems there may be a difference in conduction velocity between the medial and lateral giant fibers. Do you think this has to do with the axon diameter size difference, or perhaps the difference in the amount of myelin wrapping the axons? We would love to hear what you think and what measurements you got. Thank you for watching. Until next time, have fun discovering and learning.